Okay, let's unpack this. Think about energy today. It's messy, isn't it?
It really is.
We're all wrestling with costs that jump around like crazy, driven by everything from global events to, honestly, just whether the sun's shining.
Yeah.
Add to that the push to be more sustainable. And your energy setup isn't just a wire to the street anymore. You've got solar panels, maybe an EV, smart batteries. It's this complex, shifting picture that feels almost impossible to truly get your head around, let alone control efficiently.
And trying to manage that manually or just reactively is like driving by looking only in the rearview mirror. You need intelligence, you need foresight, and, well, you need it built into the system itself.
Right. That's where we're diving into Stromfee.AI. They've essentially built a platform designed to bring sanity and control to this exact chaos. And based on the material you shared with us, we're going to pull back the curtain on their core engine, what they call the energy transformer flow.
It's their entire process, really, start to finish, how they ingest all that raw, disparate energy information and turn it into something truly valuable for you. Clear insights and automatic actions that actually optimize things.
The sources draw a fascinating conceptual link here, right, to the idea of an academic energy transformer model.
Yes, it's a powerful analogy. In certain fields, these models can take very scattered, incomplete data points, like sparse measurements of fluid flow, and reconstruct a complete dynamic picture of the entire system.
Okay.
Stromfee.AI aims to do something similar for energy data. Your energy footprint is full of sparse points, a meter reading here, a device turning on there. Their flow uses AI to sort of reconstruct your full dynamic energy reality, filling in the gaps, seeing the connections.
Giving you a comprehensive understanding you wouldn't get from looking at individual points.
Exactly. You get the whole picture.
So our mission for this deep dive is to walk you through this flow. We'll explore how they gather the data, how the AI transforms it, what kind of intelligence it creates, how that translates into tangible action, and, the tech that underpins it all.
Right. It's about understanding how the sophisticated approach delivers real benefits.
And like any system powered by intelligence, it all begins with a foundation, the data itself.
Absolutely. You need good data in.
The genesis of insight, data ingestion. This is where Stromfee.AI starts building that dynamic picture by casting a pretty wide net for information.
The beauty here is the sheer range of data they can pull in. It goes far beyond just your main smart meter reading.
Okay.
You've got that overall usage data, yes, but then they integrate with specific hardware to get incredibly granular.
Like devices that monitor individual circuits or appliances, is that the idea?
Exactly. Devices like smart switches and meters from brands like Shelly. These provide real-time data down to a specific appliance or circuit, knowing exactly when your water heater kicks on, or, say, how much power your server rack is using.
And for those generating their own power, like with solar.
Yep, they integrate data from combined heat and power plants, CHP, and photovoltaic PV systems, tracking output and efficiency. And energy storage systems like batteries to know their state of charge and performance, health, that sort of thing.
I was interested to see they even look at parts of the grid infrastructure itself.
Yes, monitoring transformers is mentioned, specifically looking at things like idle and load losses. It's about spotting even subtle inefficiencies that could be costing you money, hidden waste.
What about those big energy users like EV chargers or systems in larger buildings, hotels maybe?
Specialized loads are key. EV wall chargers, for instance, tracking patterns and energy procession is vital for optimizing charging.
Right.
And in commercial settings like hotels, they can monitor distinct subsystems, HVAC, lighting, kitchen equipment, wellness areas to get a really detailed picture of energy use across complex operations.
So that's a whole host of internal energy sources. But external data is also critical for context, right?
Yeah.
You need the outside picture too.
Absolutely crucial. Real-time spot market electricity prices from major exchanges like EPEX Spot or ETSOE are integrated. This is vital because prices can change minute by minute.
Wildly sometimes.
Exactly. And knowing that is fundamental for the AI's optimization strategies. And weather forecasts, temperature, irradiance for solar, wind are essential for predicting generation and demand.
Pulling in all these diverse sources is one thing, but the sources emphasize real-time data collection. Why is that so important here?
Because intelligent action needs to happen now. If you're reacting to data from hours ago, you've missed the opportunity to shift load during a cheap price dip or catch an anomaly as it starts.
You're always behind the curve.
Totally. The speed is enabled in large part by protocols designed for this kind of environment.
Like MQTT. That comes up a lot.
Yes, MQTT, message queuing telemetry transport. The sources highlight its role as the backbone for connecting many of these IoT devices. It's lightweight, efficient, built on a publish-subscribe model.
So devices just send out data.
Devices can quickly publish data, yeah, and the central system subscribes to what it needs. It enables that rapid two-way communication essential for collecting data and sending back control commands in real time, even from devices with limited resources. Some edge devices, like the Shelly EM Gen 3, even log data locally for a bit.
Okay, so we're talking about collecting everything from basic consumption, kW, kWh, power quality metrics, generation data, volatile market prices, MWH, operational stats, environmental factors, all with a focus on being as real-time as possible.
That comprehensive, timely data set is the raw material. You really can't build intelligence on a shaky foundation.
Agreed. Which brings us to the fascinating part, the AI crucible. This is where that flood of data is transformed into something truly intelligent and useful.
Right. This is where Stromfee.AI's, let's say, magic happens. The central hub for this processing is what they call the Stromfee Diary, or KI Stromfee Tagebook. It's presented as an AI-powered system, not just a simple data log.
It's more than just storage, then. It's actively doing something.
Much more. It aggregates, models, and constantly analyzes that incoming data stream, building and maintaining a dynamic digital model of electricity consumption that is unique to your specific system. It's designed with a user-friendly interface, too, showing you what's happening in plain sight.
And what kind of intelligence does this system actually create? What's the AI doing?
Several key AI capabilities are at work within it. First, there's predictive analytics. The AI learns from all that historical data it's collected to anticipate future energy behavior.
Forecasting, essentially. Predicting the future.
Yes, but targeted forecasting. It predicts your energy consumption patterns, forecasts electricity prices on those volatile spot markets, and predicts renewable energy generation from your solar or wind setups, if you have them.
And how does that help?
Well, the insight here is how these predictions enable proactive action you can optimize based on what's likely to happen, not just react to what has happened.
Okay, that makes sense. Now, here's where it gets really interesting for me. Pattern recognition and anomaly detection. The AI isn't just predicting the norm, it's spotting the unusual.
Precisely. It automatically finds significant trends and inefficiencies, but crucially, it detects anomalies, things that shouldn't be happening, like discovering a specific load is spiking unexpectedly every afternoon, or identifying excessive consumption overnight when everything should be quiet.
Things you'd never notice just looking at a bill.
Exactly. The real insight is how it finds patterns you'd never spot manually across vast amounts of data.
And catching those issues in real time can prevent significant costs or, problems down the line.
That's the power of it. And beyond just analysis, the AI employs automated optimization algorithms. This moves from understanding to doing.
This is where the system takes action. Automatically.
Yes, it can automatically control devices or adjust energy patterns based on its analysis and predictions. Their flagship feature here, highlighted in the sources, is the Spot Price Manager.
Ah, the one that helps you use power when it's cheapest.
Yeah.
I saw that.
Exactly. It monitors those real-time market prices and, based on your preferences and the AI's forecasts, can suggest or automatically shift high-consumption tasks like running the washing machine or charging an EV to when electricity is cheapest, especially if you have dynamic tariffs.
And that leads directly to load management or shifting, right?
Yeah.
Moving usage around.
Precisely. Intelligently deferring or advancing energy-hungry activities to avoid costly peaks or align with periods when cheaper, potentially renewable energy is abundant. The sources mention potential savings here that are quite significant figures, like 30% or even 40% reduction in costs are cited in some places.
That's substantial. And battery storage plays a role here, too.
Oh, big time. The AI can optimize battery charge and discharge cycles, charging when prices are low or solar generation is high, and discharging during expensive periods or peaks to save money or maximize self-use.
We touched on digital twin concepts earlier. How does that concept integrate here in the processing phase? What does that actually mean in this context?
The source material brings it up as key to the personalization. The system creates a virtual replica, a digital twin, that represents the unique energy profile and behavior of your specific home, business, or system.
So it's not a generic algorithm. It's learning your specific habits and equipment and setup.
Absolutely. The AI analyzes this personalized model. This is why the insights aren't generic. They're tailored to your energy reality. It allows for sophisticated simulations within that virtual model and predictive fine-tuning of the automated actions.
making the optimization much more accurate and effective than some one-size-fits-all approach.
Exactly. More robust, more tailored.
Okay, so the data is in, the AI has crunched it, found insights, made predictions, figured out the best actions. Now what? How does all that intelligence translate into something you, the user, can actually see and benefit from?
Right. That's the transition from analysis to action. First, how the intelligence is presented. The primary way is through real-time dashboards and visualizations.
The Stromfee diary interface we mentioned?
Yes, that intuitive interface is key. It gives you those clear visual summaries of your energy flow, costs, savings, what's going on. The sources also mention Grafana in the context of their blog.
Grafana.
Oh.
That's known for powerful time series data visualization, isn't it?
Yeah.
Or technical.
It is. Well, the main user interface is designed for accessibility. Mentioning Grafana suggests that maybe for users who want to dive deep into the raw data or potentially for internal analysis by Stromfee, the system is built to support more advanced visualization.
So layers of detail available.
Yeah, it hints at a multi-layered approach to data presentation, catering to different levels of user interest.
And beyond just seeing it, you get alerted if something's up.
Yes. Automated reporting and custom alerts are a crucial part. Reports can summarize your usage, highlight where savings were made, like those from the Shelley Switcher reports mentioned, track performance over time. And automatic notifications alerts are vital for catching deviations or thresholds being crossed in real time.
Like getting a warning on your phone if something unusual is happening.
Precisely. The sources give a great example of this for specialized applications like biogas plants, where getting critical alerts instantly via smartphone, Telegram, or WhatsApp can prevent significant issues. Very important there.
Okay, so that's how you see and monitor the intelligence. But the action part, the automated energy management itself, this is where the system takes control.
This is where the AI actively manages things for you, based on all that processing, according to the rules you set, of course.
How does it connect to your actual appliances or systems to do that?
Through integrations and control components. We mentioned Shelley switches earlier for data collection. The AI Stromfee Shelley switcher component uses the AI's predictions and real-time data to automatically control devices connected to those switches, turning them on or off at optimal times.
And they integrate with other home automation systems, like LockZone.
Yes, LockZone integration is mentioned specifically. Stromfee can provide LockZone systems with real-time spot price data, potentially via a MySQL database, as the source suggests, allowing LockZone's own logic to leverage that dynamic pricing information.
So they can work together.
Exactly. There's even a customer case study highlighted where using this flexible pricing data coupled with Stromfee's control and a CHP unit led to a really drastic cost reduction, like huge savings.
Wow. What about broader connections beyond specific systems?
That's where IFTTT, if this then that, comes in. Integrating the Stromfee diary with IFTTT opens up huge possibilities for custom automation rules. You can link Stromfee's intelligence to a vast ecosystem of other services and devices.
So you could set up your own custom automations.
Totally. The sources list great examples. Automating heating or cooling based on detected patterns or price signals, optimizing when hydro appliances like washing machines run, controlling smart lighting based on energy conditions, or even managing commercial HVAC and lighting systems more efficiently. Optimizing data center cooling is another one mentioned.
So it's about connecting to existing systems and enabling new automated actions based on the AI's analysis and the price signals.
Exactly. This all enables a dynamic response to market conditions. The Spot Price Manager automates reactions to low prices, but the system can also support demand response, automatically curtailing non-essential loads during price spikes to save you money and also, importantly, help stabilize the grid.
It sounds like a lot of automation, which is great, but the sources stress that the user isn't left out of the loop, right? You're still in charge.
Not at all. User empowerment and interaction are central. Despite the automation, you remain in control, setting your preferences, defining the rules and thresholds for the AI, and having the ability to override actions anytime. The platform is designed to be user-friendly.
Making it accessible.
Yeah, giving you the data and tools to make informed decisions yourself, even while the automation handles the day-to-day complexity.
Okay, let's briefly touch on the underlying technology. What's the backbone that makes this entire energy transformer flow possible?
Right. The technological backbone relies on carefully selected platforms and integrations. We've talked about MQTT, but let's re-emphasize its critical role for a second.
Why is it so crucial for this specific system? You mentioned it for IoT.
because it handles the communication needs perfectly for this kind of distributed energy ecosystem. It's built for the Internet of Things, real-time, efficient, scalable, and bidirectional communication between the central intelligence and potentially hundreds of edge devices. It's a choice that helps ensure the system can grow with the complexity of modern energy setups. It's future-proof in that sense.
And handling massive amounts of time series energy data requires specific database solutions, doesn't it? You can't just use a standard database.
Absolutely. Energy data is high volume and time-stamped. The sources strongly indicate InfluxDB is used.
Which is specifically designed for time series data, like sensor readings over time.
Precisely. It's ideal for this application. High-speed data ingestion from all those real-time sources, efficient storage through compression, powerful real-time querying needed for the AI's analytics. And it scales well. It makes a lot of sense as the core database fueling the AI.
And they also mentioned MySQL. Why both?
Yes. In the context of providing data to Lockzone, they mention using a MySQL database for spot market prices. This suggests a hybrid approach makes sense. MySQL is great for more structured data like user settings, device configurations, or maybe specific data feeds required by other systems.
Like that Lockzone price feed.
Exactly. It complements InfluxDB's role for the high-volume time series measurements, different tools for different jobs.
And the ability to connect to other systems, the integration ecosystem you mentioned.
That's fundamental to making the system practical in the real world. We've seen examples: Shelly devices, Lockzone, IFTTT. Amazon Alexa integration is also hinted at, potentially allowing voice control.
And the mention of a Lockzone API interface suggests Stromfee.AI itself probably offers ways for others to connect.
APIs.
It's highly probable, yeah. Building a platform that integrates with others and is adaptable for specialized applications, like those for biogas plants, implies an open architecture, likely supported by APIs, allowing for custom integrations and expanding the ecosystem, makes it flexible. So we've seen the data come in, get transformed by the AI, and turn into actions and insights delivered to the user, all powered by a specific tech stack. What's the ultimate payoff? Let's talk about the impact equation. What does this transformed data actually do for the user?
Well, the most tangible benefit, the one everyone feels first, is significant financial savings, economic advantages.
We've heard some potentially big numbers mentioned.
Yes, potential cost reductions up to 30% or even 40% are cited in the materials. And that customer case study you mentioned, going from 5,000 euros down to 800 euros, using flexible pricing and Stromfee's control with a CHP unit, I mean, that's a really powerful real-world example.
That's huge.
It is. And this isn't just theory. It's achieved through things like the spot price manager, avoiding high prices, reducing expensive peak loads, and even finding those hidden inefficiencies like transformer losses. There's also a bill verification service mentioned.
Beyond money, there are operational efficiency gains, particularly maybe for businesses.
Definitely. The system increases overall energy efficiency across your operations, optimizes processes automatically, and provides preventative maintenance capabilities by spotting anomalies early before they become big problems. It ensures energy is distributed optimally and drastically reduces the need for manual oversight and adjustments, frees up time.
And for the broader picture, what about sustainability contributions?
Absolutely. This is a key part. By shifting your energy use to hours when grid electricity is cheaper, you're often using power when there's more renewable generation available in the mix, so you're directly reducing your carbon emissions.
Interesting link.
Yeah. It also maximizes your use of self-generated renewable energy, like solar using it when you make it or storing it intelligently. And by helping balance load and reducing demand during peak times, it supports the grid's ability to integrate more renewables overall, making the whole system greener.
And from the user's perspective, it sounds like enhanced convenience and control are big factors too.
For sure. The automation takes care of complex tasks, like constantly monitoring prices and adjusting device timing, which adds a significant layer of convenience. Let the system handle it.
Set it and forget it, to some extent.
To some extent, yes, within the parameters you define. The user-friendly interface makes this advanced management accessible even if you're not an energy expert. You gain empowerment through clear data and control.
So the benefits aren't narrow. They seem to ripple out economic, operational, environmental, and improving the user experience all tie together.
They're absolutely interconnected because smarter energy use inherently delivers across all those dimensions. It's a virtuous cycle.
Okay, let's quickly recap this journey then through Stromfee.AI's energy transformer flow. It's quite a process.
It starts with acquiring incredibly diverse, granular, and real-time data from smart meters, device-level sensors like Shelly, generation systems, storage, and external feeds like market prices and weather, all brought in efficiently using technologies like MQTT.
That data then flows into the intelligent processing core, the Stromfee diary, where AI capabilities like predictive analytics, pattern recognition, optimization algorithms, and that personalized digital twin concept transform it into deep insights and precise directives.
And finally, that intelligence is delivered as actionable output and automated control visible through dashboards and alerts, and enacted by controlling devices and systems directly via integrations with platforms like Shelly, Loxone, and IFTTT.
The core outcome, the bottom line, is the transformation of raw energy data into tangible benefits for you, significant cost savings, increased efficiency, and contributions to sustainability.
You know, this model really represents a paradigm shift in energy management. It's moving from simply tracking what happened yesterday to actively predicting and shaping your energy future. Proactive, not just reactive.
And by making these sophisticated tools accessible to homes and small to medium businesses, not just huge factories, it's kind of democratizing advanced energy management.
That's a great way to put it. It's fundamentally facilitating the energy transition by providing the intelligence needed to manage the increasing complexity of integrating renewables and distributed energy resources effectively.
Turning passive consumers into active participants.
Exactly. Active participants and managers of their energy footprint.
It really positions Stromfee.AI's approach as part of that wider digitalization wave sweeping through the energy sector, leveraging IoT, AI, cloud, advanced analytics to tackle universal challenges in a smarter way.
It's definitely more than just one company's platform. It feels like a potential blueprint for how intelligent data transformation can unlock significant value in a complex, vital domain like energy.
Which leaves us with a final thought to consider, something for you to mull over. How this intelligent transformation of data, exemplified by systems like Stromfee.AI, is not just optimizing energy bills, but is fundamentally changing our relationship with energy itself. So the question is, what other systems currently generating vast amounts of raw data, think about healthcare, transportation, agriculture, you name it, could be similarly transformed by AI? Where else could we apply this kind of transformer flow to unlock hidden value for cost, efficiency, and sustainability on potentially an even larger scale?
What domains are really ripe for their own transformer flow? It's a fascinating question.